In this recording, we're going to be doing a review of LeChatelier. I call it my LeChat review, and what I've done is set this up in my notebook file so that if you want to, you can go to this page and actually work problems, and then there's problems that I'm going to be working, which you would want to copy down right now so that you'll have them, either copy it or print it. Do a print screen, and there's the next problems. Okay, so these are all the problems that I'm going to work on that worksheet, and if you print these out by just doing a print screen, you will be able to have them with you and looking at them as I actually describe what the problems are. Otherwise, you wouldn't have this textbook likely. This is the Zundel Introductory Chemistry, a Foundation, 4th edition, which our school used several years ago, and I frequently go back to it to get extra problems. So here we go. Let's get started. Okay, all of these first problems, 36, A, B, C, D, and E, are working with the same equation. UO2 as a solid plus 4HF going back and forth in an equilibrium to UF4 plus H2O, and the H2O and the UF4 are gases, as is the HF, and then the UO2 is a solid. So that affects how these equilibrium are figured out, as you'll see in the very first one. So let's go to letter A, and in letter A it says that the thing that they want to do to stress this particular system at equilibrium is to add UO2. And so the UO2 is going to be added, which will increase the amount of UO2. Well, LeChat is the guy that wants to put everything back the way it was. So with LeChat, what he wants to do is he wants to put it back by decreasing the amount of UO2. However, he's got a problem. And his problem is that UO2 is a solid, and solids do not affect equilibrium. So it is impossible for him to affect the shift, and so there is none. There is no shift. Just not going to happen. Write that a little more neatly. Okay, there we go. So that one was fairly easy to figure out. Next one, they're going to add this Xe, the xenon, as a gas, and xenon is going in, so that increases the amount of Xe, and LeChat would just love to take that stuff out. Okay, and so that's what he wants to do. But we have another situation where he can't, and the reason that he can't is because xenon is not part of that balanced equation that we're using as the equilibrium thing. So again, we wind up with none. Okay, and the next one. See, what we're doing is we're figuring out what the shift is going to be. And that's what you're going to be asked on tests. Now, in letter C, the reaction is performed in a glass reaction vessel, and HF reacts with the glass. Okay, it says it attacks the glass, but if it attacks the glass, it's actually reacting with it. So if it reacts with it, it's going to get used up. And so the HF as a gas is going to come down because it's done in a glass vessel. So we got HF over here. LeChat wants that stuff to increase. And so he wants to, we need to tell how he's planning to do that. Well, HF is on the left side of the equation. And when we want to increase things, increases are always moving the reaction to the same side as the stuff that we are messing with. In this case, we're messing with HF, hydrofluoric acid. So if you look up here, you'll see I'm giving you some reminders that you might want to write down. Opposite means decreasing the amount. This is what LeChat will do. He's going to go opposite if he wants to decrease, and he's going to go same if he wants to increase. And we're talking about HF now. So we're going to have a same type deal here because he wants an increase. And HF is on the left side, so the same side that the HF is on is the left, and that's where the shift is going to go. So this is going to be a left shift. And now we go to letter D, water vapor. H2O is removed. So that means the water has gone down in concentration. Well, LeChat, of course, wants it to go up. So again, because we're talking about an up arrow, that means we're going to have to go to the same side that the water is on. And the same side that the water is on is the left side, because that's where water is. So that takes care of our water vapor. Now the next one, this is a little different. The size of the reaction vessel is increased. Well, if we increase the size of the reaction vessel, that is going to decrease the pressure, because volume and pressure are inversely proportional according to Boyle's law. So what are we doing? The vessel is increased in size. That means the pressure is down. So I'm going to abbreviate pressure here. Pressure's down, and the pressure, according to LeChatelier, should be going up because he wants to put it back. Now, to go up, we're going to have to do something different than same and opposite. This time we've got to figure out where we have more moles. We have more moles by counting the coefficients on each side of the equation. So let's start with the UO2. Well, UO2 is a solid, so it doesn't count. It's not going to affect the equilibrium, so we can't count it. However, the HF has a 4 there. Now on the right side, we have UF4. The coefficient of UF4 is assumed to be 1 because there's no coefficient there. And the coefficient of water is 2. So we have a total of 3, 1 for the UF4 and 1 for the H2O. So there's 3 on the right, 4 on the left. So we want to increase the pressure. We've got to go to the side with more moles. Okay, more moles is on the left, and so the shift in this case will be to the left. Boy, we're going to the left a lot, aren't we? Okay, that takes care of problem number 36. Let's go to problem number 37. It says that this guy is endothermic, and I want you to look right down here at the bottom, and I've told you where the heat is for endothermic and exothermic. Heat is treated just like a reactant or a product. And so what we have to do is look and see what where the heat is. Now, endothermic reactions, the heat's on the left. So let's see. Heat's on the left, and what would be the effect of the position of the equilibrium if it were performed at a lower temperature? So temp is down, and LeChat, of course, wants to get temp up. And this is common. This kind of stuff is what you tend to see with exo and endothermic reactions. Now, because this guy is endo and the heat is on the left, and we want more, okay, we have to go to the same side that the temperature is on. And the temperature, again, because it's endothermic, is on the left, and so we're going to shift to the left. And that will make more heat. All right? So let's go on, and the reaction. In this one, we have another endothermic. So the heat's on the left again, and they're increasing the temperature. Temp is up. LeChat wants the temp to go down. And to go down, we have to go to opposite. Remember, we had this little stuff up here at the top? Okay, told you what to do with opposite. Okay, and opposite is for decreasing. Since this is endothermic is on the left, heat's on the left, and opposite of the left is a right shift. That takes care of number 38. 39. We are exothermic this time, and for an exothermic reaction, what will the shift be if, let's see, what, an increase in temperature. That is our actual stress. So temp is up, and the shot, of course, wants temp to go down, and going down is going to be opposite, and the heat on an exothermic reaction is on the right. Opposite of right is left, and that's the direction that LeChat will shift this reaction. And now we go to number 40, and in 40, increasing temperature again. Temp's up, that's the stress. They say increase the temp, and LeChat wants the temp to go down, and then to go down, again, we need the opposite. I'm abbreviating OPP for opposite. So for the temp down on an endothermic reaction, okay, endothermic, the heat is on the left, opposite means right. So this is going to be a right shift. 2 to go, and we've got them all. So number 41, increasing temperature again, temp up. Now you'll notice I have temp up in 4 problems in a row, but the shifts are different each time because of where the reaction, or where the heat is, whether it's exo or endo. So now we go temp down because that's what LeChat always wants to do, the opposite, that is. And to be down, we have to move to the opposite side again. Boy, opposite a lot here, huh? And so with opposite on endothermic, the heat is on the left, opposite of left is right. So this is another right shift. And last but not least, this thing with ammonia. This is the Haber cycle, and the Haber cycle is the way we make ammonia commercially. And they're asking us here with an exothermic reaction, exo because the heat is on the right, you see 92 kilojoules, that represents heat. So they're asking, should we perform this in a high temperature environment or a low temperature environment? So you can see that heat and ammonia are both on the right side. So we want to do something that will cause LeChat to think he has to make more heat. And more heat is on the right. So that's the shift that we're going to want to have. So what makes this a little tricky is that we can see that heat is on the right, and to make LeChat go to the right, that means we need temperature being to get LeChat to raise that temperature. And the only way that LeChat can raise temperature is if he goes to the same side the temperature is on. And the same side that the temperature on is the right side. So you see, I'm kind of working this guy backwards. And now that I know that I want LeChat to move the temperature up, I am going to move the temperature down in my stress to be able to get the effect that the question was asking me to get, which is more ammonia. Because when I make more heat, I also make more ammonia. And that's the side that we want to shift to. So we're going to shift to the right. And that fills in this little chart for all of the problems. And by the way, wouldn't you think it would be nice to build an ammonia factory in Alaska? Because it's cold up there. Oops, I got my arrow in the up direction. We really wanted that in the down direction. Okay, we want to expose our reaction to cold. So LeChat will want to move it up and make more heat. So that's how this stuff works. I hope you found this helpful. And just in case you wanted to copy those problems down, I'm going to move over there to the problems again. You can stop the recording and do a print screen of this. and you can stop the recording and do a print screen of this. And that's it. Thank you for watching.